Hello students, let us try to understand conformation. Okay, this topic we are going to understand from the NCERT. Okay, NCERT 11th standard chemistry. So what is the conformation student? Alkane contain carbon-carbon sigma bonds. Okay, alkane contain carbon-carbon sigma bond. And electron distribution of the sigma molecular orbital is symmetrical around the internuclear axis of CC bond, which is not distributed which is not disturbed due to rotation about its axis. So they are saying whatever the alkanes are, dear student, alkanes are there. They are saying that is these are the bonds are there. This is the bond, okay, and they are saying that is if you rotate this one sigma bond electron distribution in sigma bond is not going to disturb student, it's not going to disturb. They are saying this is not electron distribution of sigma, okay, no sigma molecular orbital is symmetrical around the internuclear axis of the CC bond, which is not disturbed due to rotation about its axis. This permits free rotation about CC single bond. This about yeah, this permit free rotation about CC single bond. This rotation results into different spatial arrangement of atom in a space which can change into one another. Right? Keep in mind the point, student. This permit free rotation about CC single bond. This permit because it is not going to disturb, so this allow free rotation about CC single bond. This rotation result into different spatial arrangement of atom in space which can be changed into one another. Such spatial arrangement of atoms which can be converted into one another rotation around CC single bond is called the conformation or conformers or rotamers. Alkanes can thus have infinite number of conformations by rotation around CC single bond. However, it may be remembered that the rotation around CC single bond is not completely free. It is hindered by a small energy barrier of 1 to 20 kJ per mole due to weak repulsive interaction between the adjacent bond. Such a type of repulsive interaction is called torsional strain. Okay, torsional strains will be there. Means that is whatever the rotation are there, student. Okay, suppose these are the hydrogen is there. Okay, again hydrogen is there, again hydrogen is there, here CS3. So they are saying that is this rotation is not free, student. Okay, this rotation is not free. Why? Because there is the small energy barrier 1 to 20 kilojoule due to weak repulsive interaction between adjacent bond. Such a type of repulsive interaction is called torsional strain. Now let us try to understand conformation in ethane. Ethane molecule C2H6 contain a carbon-carbon single bond with each carbon atom attached to 3 hydrogen atom. Considering the ball and stick model, considering a ball, this is the ball and these are the stick model of ethane, keep one carbon atom stationary and rotate the other carbon atom around the CC axis. This rotation results in infinite number of spatial arrangement of hydrogen atoms. So one atom is the center is the this is the fix and remaining it is going to rotate. So they are saying that is infinite number is structure is possible. Okay, rotation result into infinite number of arrangement of hydrogen atom attached to one carbon atom with respect to hydrogen atom attached to other carbon atom. These are called conformational isomers, conformers. Thus, there are infinite number of conformation of ethane. However, there are two extreme cases. One such conformation in which hydrogen atom attached to two carbons are close together are possible class called eclipse. Okay, they are saying one such conformation in which hydrogen atom attached to two conformers are or as close together possible is called eclipse conformation, and the other in which the hydrogen are far apart as possible, known as staggered conformation. Okay, any other intermediate conformation is known as skew conformation. It may be remembered that in all the conformation, the bond angle and the bond length remain the same. Eclipse and the staggered conformation can be represented by Sahars and Newman projection. Okay, so let us try to understand Sahars projection. Sahars projection. In this projection, the molecule is viewed along the molecular axis and then projected on, you know, how then projected on, how you are going to, by the drawing the central CC bond as somewhat longer straight line. Upper end of the line is slightly tilted towards right or the left hand side. The front carbon is shown at the lower and lower end of the line, whereas the rear carbon is shown at the upper end. Each carbon has three lines attached to it corresponding to three hydrogen atoms. Okay, the lines are inclined at the angle of 120 degree to each other. Sahar's projection of eclipse staggered conformation or ethane is depicted. This is eclipse because the atoms are very close to each other. This is the staggered, atoms are away. Now Neumann projection. In this projection, the molecule is viewed at the CC bond head on. The carbon atom near to I is represented by a point. Three hydrogen atom attached to the front carbon atom are shown by the three lines drawn at angle 120 to each. The rear carbon atom, the carbon atom away from the I, is represented by circle, and the three hydrogen atoms are shown attached to it by the shorter lines drawn at the angle 120 to each other. The Newman projection are depicted. Okay, so if the close are there, both are close, that is eclipse. Far away, that is what is staggered, angle of rotation or the angle of rotation, dihedral angle. So this was the confirmation. So we will study the relative stability in the later video, and thank you so much for watching, student. If you find this video helpful, please do like and subscribe the channel, and don't forget to comment. Thank you, students.